লাস্ট এপিসোডে আমরা বেসিক ইলেকট্রিসিটি নিয়ে আলোচনা করলাম। এই এপিসোডে আমরা কারেন্ট, ভোল্টেজ, কন্ডাক্টর, সেমিকন্ডাক্টর এটসেট্রা যা কিছু আছে সব কিছু নিয়ে আলোচনা করব।
A free electron in the charge carrier in the copper wire or any other solid conductor is electricity. তার মানে ইলেকট্রন যখন মুভ করে একটা কন্ডাক্টর দিয়ে, ওইটাই হলো আমার ইলেকট্রিসিটি। With no external forces applied, the net flow of charge in a conductor in any direction, in any one direction is zero. যদি কোনো আমি external forces apply না করি, তাহলে দেখা যাবে যে net flow of electron is zero and hence no current will flow. Okay, moving on to the next slide. This is how actually charge flows through a conductor and making actually the current. You can see that electrons are coming in and then moving from one atom to another, and then just like from here they're traveling to the one end to the other end and making current flow. Actually, flow of electrons is current, and this diagram demonstrates that quite easily. So current equation is I equals to Q by T. Q is the charge and time, T is the time. Charge is measured, as you all know, in coulombs, and time is measured in seconds. So if we divide charge with time, we'll get the current, basically. There are two sums for you to practice. I would like you guys to pause the video first for 1 or 2 minutes and try these two sums to sum up what we have learned up until now. Now coming to voltage. Voltage is actually the potential difference. It is the thing that is moving electrons. Okay, without voltage we would not get the current. So what happens, to just generalize something what we are going to talk about. Suppose we have 1 coulomb of charge at this point X, and we want to move this 1 coulomb of charge from this point X to this point Y. So to move this 1 coulomb of charge from X to Y, suppose we needed we did 1 joule of work. So voltage is work done by charge, So since my work done was 1 divided by the charge, which is also 1, so to move this thing, so the voltage between X and Y is 1 volts. As you can see, voltage is equals to W by Q. We had done 1 joule of work and 1 coulomb of charge, so 1 divided by 1, so 1 volts. So to move that thing, going back to the next, so move this 1 coulomb of charge from here to here, we needed 1 volts. Okay, there are like voltage symbols. This is a single cell symbol, this is a multiple cell symbol, this is DC voltage source, this is AC voltage source. These are all symbols, and voltage is measured, as you all know, in volts. Again, there is a simple sum for you guys to practice. I would again like you to pause the video for some time and try this sum and come back and see the video. Now water analogy for electricity. So if we think the height to be the voltage and the water inside this container to be the current is measured in amperes, and resistance being the cross-sectional allowed for the water to flow. So height means voltage. যত বেশি আমার পানি উপরে থাকবে, that means অত বেশি আমার voltage, আর যত বেশি উপরে থাকবে অত বেশি আমার ফ্লো হবে, অত তাড়াতাড়ি আমার ফ্লো হবে, তার মানে অত বেশি আমার কারেন্ট। যত উপরে থাকবে পানির লেভেল, অত বেশি আমার ভোল্টেজ, আর যত বেশি ভোল্টেজ থাকবে আমার, অত বেশি আমার কারেন্ট ফ্লো করবে, রাইট? সো আরো বেশি স্পিডে কারেন্ট বের হবে, সো আমার কারেন্ট উইল বি মোর। অ্যান্ড রেজিস্ট্যান্স, এখানে দেখা যাচ্ছে লেস রেজিস্ট্যান্স, বিকজ এরিয়াটা বেশি, আরামে পানি বেরো যেতে পারছে, মানে এখানে এরিয়াটা কম, সো মোর রেজিস্ট্যান্স। Okay, you can see this area is quite smaller than this one. Basic electrical circuit. So basic electrical circuit একটা normal simple circuit কি থাকে, একটা bulb, আমার তার, which is wire, and positive terminal and negative terminal. The wire is connected in positive terminal, and the other end of the wire is connected to the negative terminal. In between you have the bulb. So what happened, electrons start flowing from the negative end and then moves around this closed loop to come to the positive end. So this is the direction of flow of electrons. But traditionally আমরা কারেন্টকে ধরি opposite to the direction of flow of current. So current flow is opposite to the direction of flow of electrons. Electron যেদিকে মুভ করবে current exactly or opposite দিকে মুভ করবে. Okay. So conventionally এটা নেওয়া হয় basically আগে maybe এরকম কিছু. Conductors are those materials that permit a generous flow of electrons with very little external voltage applied. মানে হালকা ভোল্টেজ দিলে ইলেকট্রন ফ্লো করে and we get current. এই sort of জিনিসের মধ্যে আমরা বলি মানে conductors basically. আমাদের relative conductivity of several materials are shown over here: silver, copper, gold, aluminum, tungsten, nickel, iron and all. আমরা স্ট্যান্ডার্ড ধরে নিছি কপারকে. As you can see, copper has a relative conductiveness of 100. Okay, so 100 এর বেশি silver. That means silver conducts better electricity. Gold to electricity ভালো conduct করে, but slightly less than copper. Since gold is expensive, that's why I do not use. Similarly, silver is also expensive, that's why we do not use. But silver has a better conductivity than copper, as you can see from this chart. Insulators are those materials that have very few electrons and they require a large potential difference to establish a measurable current level. Insulator মধ্যে basically অনেক ভোল্টেজ দিতে হবে যদি আমার কারেন্ট ফ্লো করতে হয়. That's why they are used for safety purposes. Like average breakdown voltage দেওয়া আছে, average breakdown strength এখানে মিন করতেছে কতটুকু ভোল্টেজ দিলে a measurable amount of current will flow, a large amount of current will flow. For example, you see, for air to conduct it requires 30 kilovolt per centimeter. For porcelain it's 70 kilovolt per centimeter and oil is 140. For mica it's around 2000 kilovolts per centimeter to break that material and so that a generous amount of current will flow. So that's a lot of voltage actually. So that's why we have named these things as insulators. That now semiconductors are a specific group of elements that exhibit characteristics between those of insulators and conductors. Although silicon is almost extremely employed material, germanium, gallium arsenide are also used in many important devices. Semiconductors materials typically have 4 electrons in the outermost valence string. Normally the last shell এর মধ্যে 4টা করে ইলেকট্রন থাকে and they exhibit properties, as I have already said, between like conductors and insulators. Ammeter and voltmeter, this is a digital multimeter. That means it measures both current, voltage, resistance, everything that you need in a circuit. Practical electrical circuit, and the circuit that we draw in our copy is something that looks like this. You can see this is a practical electrical circuit of a flashlight and like two batteries, 1.5 DC volt batteries, and then you can see the bulb. And this is when you draw it in your copy, you draw something like this: 1.5 volt battery with a bulb connected. When you close the switch, current will flow and eventually you will get the bulb to lit.